But that helps the egg.
So, we're getting to the end of the year, guys. So, finish strong. Run a race so that you can finish strong. Run a race.
I felt like half the way.
Okay. Does anybody know why it's important to finish strong?
Yeah. We start out good the next.
Okay, that helps. Yeah. Spiritually.
The reward.
The reward. Okay. Aren't we supposed to do all things for the glory of God?
Amen.
Right? And just not finishing strong bring God glory.
No, we don't.
No. Okay, this is not just in school. This is anything we do, right?
Right.
But we're just going to apply it to school since we're in school right now. Cool. So, we are going to jump into chapter 8 now. Chapter 8 is all about fluids. What's a fluid?
Water that flows. Yeah.
Anything that flows.
Anything that flows. Okay, so what can flow?
Yeah.
Water.
Gas and liquid.
Cookies, biscuits.
Okay.
A boat.
You don't remember mentioning?
Oh.
Yeah, Mr. Kramer,
I just want to say, I got the green.
I got the green.
It works though. It's not really.
Ethan, you can keep it.
I know. I think we need to use a smaller cup, like a quart. You shave off some of the stuff. It's just the whole thing.
Alright, fluid mechanics. It's just really studying of fluids, how they flow, but also that forces can be transmitted through fluids. Did you guys know that? Did you know that fluids can cause a force? How do you know that? Give me an example. Give me an example. I can tell you an example. Everett? Tidal wave? Ooh, yes. A lot of energy transferring through a tidal wave, huh? Don't tsunamis do a lot of devastation? If they didn't exert a force, would you worry about tsunami damage?
No.
No. If they couldn't transfer energy through fluids, you wouldn't really worry about, big tsunamis. Okay? Any others? You ever shot your friend with a squirt gun or? Yeah? Tornado. Okay. What is that? I mean, outside of the fact that like a tornado picks up cars and slams it into your face, what of the tornado is the fluid? Yeah, the air, right? The air is gas particles, correct? get those gas particles moving fast enough, they can do some serious damage. Okay? So fluid mechanics is the study of really how fluids can apply forces and how energy can be transmitted through them. Then the next bullet says fluids exert forces and can do work. What's work? Exchange of energy, okay, into a system to cause a change in the system. And we said there are 3 things required to do work. What are those 3 things?
Force, movement, and force in the motion.
Okay. Force, movement. Force and movement are in the
Same direction.
okay. So, if fluids can exert a force, then they can cause an object to move, right? If you got a tsunami, a tornado, shooting water through a hose, that can cause an object to move, right? Okay. Fluid, then, anything that can flow. Definition of a fluid. So, most often, a lot of people are like, fluid is a liquid. Well, that is one example of a fluid. Yes?
Do you have a low energy?
I'll have to look, I don't know. Okay, I'll try to get you one this time. You can use some extra credit that way.
I love you.
Have you ever done the nose pass?
I got it once. I got it.
Okay. Thank you. I probably won't do it. Okay. So anything that can flow. So a liquid can flow and a gas can flow. What cannot flow? Solid can't flow. Okay? Your face is a solid. All right? Now, it says that all fluids what?
Assume their shape of the container.
What does that mean?
Okay.
You put it fluid into like a triangle
So like if you had a enclosed triangle with a fluid in it, it would assume the shape of that container. So like if I had a beaker and I pour water in the beaker, the water wouldn't just hang out there, would it? Wouldn't that be funny to see though?
That looks so like.
Right? Well, you wouldn't have like one there and then some over here and then some just sitting up there, right? That's not what it would look like. It would assume the shape of the container because the particles will flow on each other until gravity puts them, orients them in a place where it assumes the shape of the container. So how about like a gas, right? Gases are in this room, right? Aren't gases assuming the shape of the room? Right? Yes?
What about with the lava lamp?
A lava lamp.
There's like 2.
Okay, so lava lamps are different. First off, I believe a lava lamp has a water mixture and then wax. And the reason why the wax goes up and comes down is because of something called convection, which we will talk about actually in this chapter, because we're talking about fluids.
Whoa.
Yeah. So basically what happens in lava lamps is hot stuff rises, it cools down, drops.
Really?
Rises, it cools down, drops. That's how it works. Called convection. Okay. Alright. Pressure, pretty important thing, right? Can a fluid exert any pressure?
Yeah.
Yeah. We're going to talk a lot about pressure in fluids because there's a lot of applications of pressure. We're going to talk later about why typically usually it depends on the situation, but why usually in your house, if you have 2 showers, the one in the basement has more water pressure. How many of you have 2 showers and the water pressure in the basement is a lot more than the water pressure in the upstairs? Anybody know what I'm talking about? My house, I mean, I only have 1 shower in my current house, but when I was living with my parents, I would never use the upstairs shower because it drove me nuts. It was like, I'd rather just go sit outside and get rained on because it was just so hot. And there's a reason why. We'll talk about that. Anybody ever went to a swimming pool that has a high dive and then tried to get as far down into the water as you possibly could?
Yes.
Okay, what do you notice the further down you go in the water?
More pressure.
More pressure. It almost is like painful, isn't it?
Yeah.
Why is that?
More water now.
We're going to talk about that. Anybody ever went in an airplane?
Yes.
What happens when you go up in the atmosphere?
Your
Your ears pop. The reason why that is because of change in
Air pressure.
pressure.
How
Your ears never pop?
We should go on a field trip test. We need to go to a pool or the airplane.
Did those 5 planes get off the ground?
Yes.
It's because you've been in the plane doesn't mean you're in the air.
We should go to the spillway.
Spillway.
Oh,
Yeah, that
Shane,
would
you know what I meant.
that would probably hurt you pretty bad.
No, I'm just saying if you go there, like field trip, and watch the fluids.
That's
You want to
boring.
watch the fluids for 40 minutes.
Yes.
Yes, and
It's
Chuck Rock's
so
down
much
there.
fun.
I like boring fun.
Very much fun.
I like to see the fish.
Or when people get splashed.
Let's go swim.
Cassidy, that would kill me.
No.
Let's go on.
That's-
Let's go on high dives and,
Not right
figure
now.
out fluid pressure. Yeah.
I like that. Not right now. It's interesting.
You all right, Katie? Having a good day?
Oh, there it goes.
All right. So. Look at that.
Pick on Shane. Pick on Ethan.
Yeah, I think that's shit.
No, I actually did my anger up project. So did I.
Yeah, are you looking at me?
I did do my anger projects.
Hashtag
Hashtag not my anger up project, Cassidy. Pick on Cassidy.
That-
Ow, my toe. That hurt a lot.
That hurt?
Yeah.
Now, what if I won't use an example. So, pressure is what? What is pressure mathematically?
Force divided by area.
Force over an area. Okay? So if I can increase the force, the pressure will what? Increase. Okay? What if you increase the area of that force? The pressure will go down. So if you apply the same force over a larger area, you will have less pressure. What if you take the same force and you really centralize it to a small area? More pressure. Okay? Give you an example. If I were to walk and step on your foot with just my foot right now, it'd probably hurt. But if I were to put on high heels and I were to step on you just with the heel part, same force, right? My body, my weight, right? But all of that force in one area, one little location. Ooh, how would that feel?
Not
Like a trip to the hospital.
Not painful?
Sued.
Oh, it's not painful. Right? Painful to look at because Mr. Kramer's in high heels would be painful. But also, the idea here is, have you ever heard of like those snowshoes? That they use this idea. So if you have like a larger area that your weight is distributed through, you have less pressure, so you're not likely to sink as much in the snow. Does that make sense? Because it's taking that force and it's applying it over a larger area, and so it has less pressure pushing down on the snow, and the snow can withstand your weight a little bit more. Okay? What else? What other things? Probably gives it. Ever dropped a book like where the corner just lands right on your toe or something? It's not that it's like, oh, that corner's so sharp. No, the book's corner isn't that sharp. The problem is if it drops and the force of the book gets exerted through a small area, it's going to hurt more than if the book drops like this on your foot. That's not going to hurt that much because it's going to be over a larger area, less pressure. But if I drop it and just the corner hits, okay, same force, but over a smaller area, it's going to hurt a lot more. Okay?
Wow.
So quickly, pressure is in newtons per meter cubed, and that is the derived unit. It actually equals a Pascal. That is the unit for pressure that we are going to spend most of our time talking about. A newton divided by a meter squared is the equivalent to a Pascal, PA. It's a unit. You guys know what pounds per square inch PSI means?
Yeah,
Well, I just
there's
told you.
pounds per square inch.
Okay? Americans use PSI. Doesn't make a whole lot of sense. It's not metric. The reason why you've never heard Pascal is because it's the metric unit. And Americans don't use metric units. Because we don't like change. Okay?
Mr. Krabs like custom.
Force, still force is still what you would think. Newtons. Okay? An area is the total area of which the force is applied. It's not like, oh, it's just the total area of an object. No, it's what's applying the force. So yeah, you absolutely can put it in the back. Just, we might deal with different pressure units, but pressure, most common unit is a Pascal or PA. You have a question, Mari?
Large question.
No, they have the same symbol. Power and pressure have the exact same symbol. So how do you know the difference between power and pressure? Look at the other variables or context. Right? If you're dealing with something that sounds like a pressure type problem, probably not doing power, huh?
Probably not.
Ooh! Oh, wow,
Nice
that was
Gosh,
the corner of your phone landed on your toe.
Oh,
I
that
cried because the screen shattered.
Uh-oh. Good.
No, my Motorola.
Okay? So that's what this last bullet is saying. Really important. I've given you like 12 different examples of this, but the larger the area over which the force is applied will lower the pressure, and if the area is applied over a smaller area, the pressure will what? It's opposite, guys. You don't even have to think about that.
I understood the question, so.
Then listen.
I know, I was.
You were spacing out.
Wait.
Okay.
We were
Fine.
all
It's Pascal, scalar.
Oh,
We'll say scalar. I don't think we would need. Well, no, hold on.
Okay.
yes.
Don't put any, because we'll probably treat it like a scalar, but it probably is very much a vector. So don't write it down. All right, you place a flat book on a table. The book exerts 10 newtons of force on the table, and the book's cover has an area of 0.058 cubic meters. What is the pressure? So we should probably do what first? Get out
Gotta label them.
Go get your calculators, ladies and
It
gentlemen.
was the first
Dad,
step.
you have to label.
Okay, yes, you need your calculators, but what is the first thing we should do?
Label.
Label. All right, Johnny, give me a label.
Force is 10 newtons.
Force is 10 newtons.
Yes, Dad.
Rose. All right. How much experience do you guys have with area? I'm more talking about, could you identify the area of something by its unit well?
No.
Probably not.
Some of you can. So maybe do you need to put the most common, do you need to have in the back of the book most common unit for area?
Yes.
So your area is going to be that, the symbol is A. It's going to be any distance unit squared. So probably most likely a meter squared. Because if you're trying to find the area, don't you multiply two sides, length times width? Doesn't that give you the area? So if you have 2 meters times 3 meters, you should get 6 meters to the second power. Okay? What?
L times W for M squared.
Well, L times W is not the unit. Length times width. Yeah, I mean that's the equation for getting here. But the unit will always be some distance squared. Okay? And what is our typical distance unit though? Meter. So
Meter.
it would make sense that since our most typical distance unit is a meter, and if we take two distance units and multiply them by each other, you're probably just going to get a meter squared. Okay? So, then pressure?
You don't know. Because you don't know this.
Can you solve?
Yeah.
Go.
172.4.
They don't say it out loud because some students will take that and not even try.
Well,
Yes, that is their own fault, but help us out. Don't empower them.
What did you get? What you got?
what'd you get?
No, remember the unit. If the unit's squared, the only time you square a math problem is if the variables are squared. There's no square here. The unit can be squared.
If you do that, yes, I can.
So force.
And you don't put the 0 before the decimal. Why don't
So we do not square this number because it's the unit that is squared. Okay? So when you would solve this, your unit would be a Newton/meter squared, which is a what? What did I say a Newton per meter squared was? So you could just, instead of putting a Newton/m squared, you could just write Pascal. So what did you guys get when you divided? 172 point what? Ball. And I can, if you want, not the capital A. If you want, you can just leave it as a Newton divided by a meter squared. Guys, if you're doing a math problem, I don't know if you guys remember the work problem. Work was force over distance. Okay, and the force, let's say the force was 10 newtons and the distance was 5 meters. Okay? If you didn't remember what the work unit was, first off, what is the work unit? A joule. Okay? But you could have done this. That's also right. Because a joule is a Newton times a meter. So if you don't remember the most common unit, don't put a unit in there that isn't even in there. Right? At the very least, just keep the units the way they are. Don't try to throw in a Newton here or something different. Okay? So if you can't remember what a Pascal is, don't freak out. Just leave it as the units that are in there. Because a Newton divided by a meter squared is the same thing as a Pascal. Right? So, next one. You guys do it. Mari. This one's going to be a little bit tricky. Not a lot, only because I gave you scientific notation. What's my big reminder about how to do scientific notation, guys?
I don't remember.
Anybody? When you put it in your calculator, what's the important thing? Parentheses. Parentheses. All right. You guys
could have
saw.
done that instead of just making it a decimal? Wow. Same 10 newtons, but what's all that vowel around? Oh my gosh.
I'm thinking, ooh, that's a big number. Look at the context. We said pressure was force over the area. If we have a really small area that we're applying 10 newtons, that's going to be a really large pressure, isn't it? Okay, so show me, I will come around and check. Yep, just make sure you have the right unit. Yep. 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 Yep.
It was popcorn. We got it home.
Yep. Go on. You have the answer? What'd you do it?
Be like, they're just hanging in here like,
Okay.
what did you draw?
Q 4.9. Parentheses around everything. La la, la la. Okay, I want to see from everybody. I'm not letting people squeak away. Oh, you squared it again. Why are you squaring it? Don't square this. This equation doesn't have anything squared in it, so don't square the unit.
To be honest, this is actually
Yep. Who have I seen? Have I seen Jeremy?
I It's like a bird dragon.
Ah. Yeah. Yep. 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 Yeah.
You don't want to eat this.
Okay, so I think I saw everybody 20,000, like 400 something. Is that right?
Do it.
Get that down.
This
There
last.
it is, yep.
Yes.
Alrighty.
So
Continuing on about fluid. Fluid.
I want food.
Fluid pressure. Holy, it's kind of hot in here, isn't it? I know.
Open the window.
Oh, no, let's have sauce outside.
It's so cool, but
It melted a little bit.
well, it's still small.
But you want to know, it's April and there's snow.
Excuse me.
Hey, I grew up in North Dakota. We had snow in June once.
That's so
I agree.
cool.
Remember that 1 year
Well,
where
this
we're
is it.
living in street farms had to close because
This
the
is
snow
Iowa.
day?
I was.
Yes.
I don't
That was
have it
our-
3 seasons in one.
Yeah. Yeah, that's true.
Fluid pressure.
Hey,
I was what?
that's Iowa fit 3 seasons in 1 month.
Oh, yeah.
Hot.
I was not wrong.
I mean, if you like having the variety of multiple seasons in a month.
Just no, no.
August.
Supposed to be some like.
August we have years backwards.
Yeah.
That's good. In January. And
Well, it's January right now. Oh my word, they say that's not good. Grammar.
Yeah.
Did you get the solo yet?
It's a bit long now. You go to PC servers and see if you can get a bunch of solos.
Well,
I've been enjoying playing with my younger brother.
seriously?
He's really good.
Is he on PC?
No.
When you play solo, you have to play against other PC players.
I get munched. It's probably why I'm not getting better as fast, because I get into a match and I don't even get a shot off. And people like kill me before I even get a shot
That's why
off.
his ninja's bopping.
Like 4,000
But I'm
meters
writing
away.
and I can't do. I'm
You
not
should play
good
with somebody
multitasking.
with a mobile and then get to another mobile.
Yeah.
Really, you multitask every time you sleep.
I think
You're
cross-platform
breathing
is
and sleeping
everything,
and breathing.
Like,
Huh?
right? Like,
Even. Nah, I don't
like
I
when you
haven't
play
tried that.
cross-platform has mobile.
Breathing is an
If they're playing with somebody that's
You're not
not on
multitasking.
cross-platform.
Well, it says it up on the top, it says same platform or cross.
Yeah.
Before you start.
But like if you have someone playing on a phone and someone playing on a PC, that's going to be on the cross-platform.
It is?
Yeah.
What, gonna do this the old fashioned?
I don't think it's like, oh, when you play cross-platform, you only play with, like if I play with PlayStation, does it mean that I couldn't see a mobile person?
Yeah.
I don't know that for sure, but
that would make sense.
Because they're eating my project.
because do they have multiple
You get to
cross-platforms?
take
I'm
your
assuming they only
project
have one.
Yeah.
Eat it, children.
Okay, you guys got this in?
No.
Fluid pressure, this is important here. Okay, great stop it.
Yeah.
So, so we just talked the previous slide just about pressure. This is specifically fluid pressure. What's interesting about fluids is they can exert a pressure all the way in all directions inside the fluid. So if I have a beaker of water, the water particle up here exerts a pressure, the water particle here exerts a pressure, the water particle here exerts a pressure, and so really what you have is the fluid exerts a pressure in all areas of that particular fluid. This is why when you blow up a balloon, like you don't see oddly shaped balloons usually. You don't see like this middle part hardly having any pressure and the highest part. You usually see a pretty uniform balloon. Now, can you manipulate the balloon to cause it to have funny shapes? Sure. Okay? But the fluid will apply a pressure everywhere. If it didn't, it wouldn't be able to have the shape that it has. Now, does this mean that the pressure here is the same as the pressure here? No. Because we know that when you jump in a pool and you go down in a pool, the pressure changes. Okay, so when I say pressure is exerted everywhere in a fluid, that is true. But it doesn't mean the pressure everywhere in the fluid is the same. There is a pressure everywhere, but it may not be the same. And we're going to figure out and talk about what the number one factor is that affects pressure. Any ideas? What do you think the number one factor that affects pressure is? In a way, roundabout way. Height or depth. Why do I say height or depth? You could go down, right, in water, or you could go up in the atmosphere. Okay? And we'll talk about that as we progress. Okay? Okay. So, part of the reason why a fluid can exert pressure in all directions is because of its ability to flow or move. Okay? If it was just standing still or staying stationary, it wouldn't be able to exert a pressure everywhere. Okay? But because fluids have the ability to flow all over the place, you have a force applied or pressure applied in every direction. Okay? And there's your most common SI unit, the Pascal. I've already told you about that, so I think we can move on. Questions on this? I think this is the last slide. Let me make sure. Yeah. Okay, a fluid's weight determines the pressure of at a given point in the fluid. Let me explain what I mean here. And I want to make sure that you guys have this in before I talk too much. I'm going to keep you a minute waiting. have weight. Yeah, right? Even gas has weight, right? It's a particle, it has a mass, correct? So can gravity pull down on it? Yeah, weight is the force due to gravity on a mass of on an object that has mass. So if air has a mass, gravity can pull down on it, giving it a certain weight, correct? Now, what weighs more? Air gas molecules, or liquid water? Liquid water, right? Because it's more compact. Okay? But listen here, it says a weight determines the pressure at a given point. Is there more pressure here or here? At the bottom. Experience tells us that. Okay, now listen, here's why. Isn't there stuff above this point? Think of like a doggy pile. You guys know what a doggy pile is? Okay, if I lay on the ground and all of you guys jumped on top of me, the more people that are on top of me, the more force or pressure I would feel, right? So please don't stop backing up. I might take 2 minutes here. Okay? If I'm at this point, I have a lot of water molecules above it, thus stacked on top of it, increasing the weight or force at that point. So the further down you go, the more stuff you have above you, and the more pressure you have. This is why water pressure almost entirely depends on depth or height. Okay? As I go down in the ocean or some liquid substance, I have more stuff on top of me exerting more pressure. If you go up in the atmosphere, what happens? So say this is the atmosphere here. Okay? What, is there more pressure there, or is there more pressure here? Pressure here in the atmosphere. Why? Right? There's more air above me right now, right? But if I go up in the atmosphere, I have less air above me, right? So I have less weight of air above me exerting a force or a pressure down on me. Does that make sense? Okay, so this is why when you go up in an airplane, what you're doing is the pressure goes down because you have less air above you weighing you down. Does that make sense? Okay, so the number one factor is the height or depth. However, there are a few other things that matter. Density. The more dense it is, the more it weighs. This is why if you go down in water, it has a greater change in pressure than if you change the height or depth of air. That makes sense? Okay, because water has more density, more weight. So if I go a meter down in water, I'm going to feel a bigger change in pressure than if I go a meter down in the air, right? Because air weighs less. It's less dense. Okay? All right, we're done. You have lunch, dude? No, I don't actually. What do you need?
I was come and work on it.